Hi, my name is Felipe and I'm part of the LxUs team, and I'm here today to tell you all about our biosensor. So imagine that you want to measure the quantity of valproic acid in your blood. You have to go to a clinic, you take a blood test, and in a couple of days you'll get the results. With our sensor, however, the time of the analysis is much shorter and you can do this test anywhere you are. But how does it work exactly? One fundamental component of our idea was to bring STAT3, which is already used as a therapeutic target in cancer research, into the study of epilepsy. We also found out that VPA binds directly with HDAC3, and this feature is what makes it possible for our biosensor to be able to measure only the fraction of VPA that is free, which means it's not connected with albumin. Then HDAC3 will form a complex together with STAT3. And this complex will inhibit the phosphorylation of the STAT3. As a result of this highly specific inhibition, STAT3 does not suffer dimerization. Moreover, we also looked at the action of ferrocin, which will have a key role in generating a signal that we can then read. Due to COVID-19 restrictions, and because we wanted to support our idea, we had to use a biochemical software, Python. The software enabled us to look at specific binding sites of interest, such as the VPA with the HDAC3, as well as the ferrocin with the STAT3. And with our simulations, we came to the conclusion that the binding sites that we were interested in were actually highly specific. Now that we've gone through the molecular pathways for the detection of the VPA, how exactly are we obtaining a signal? Well, for this purpose, we use the screen-printed gold electrodes on which the ferrocin reaction will take place, and the Sensit Smart device, which is a potentiostat sold by PalmSense. And then, how does the mechanism exactly work? Well, let's keep it simple. If you have VPA in your sample, the dimerization of the STAT3 is going to be inhibited, as we've gone through, and then a ferrocin reaction will take place. If this reaction takes place, electrons are transferred and the current is created. As you have a current, how is this current converted into a concentration quantity, let's say? Well, we used a square wave voltammetry. And in this picture, you can see the oxidation peak of ferrocin, and you have to see that if there is more VPA in our sample, this oxidation peak will also increase. In order for us to obtain these specific values, we have to go over these experiments a considerable amount of times so that a calibration curve can be obtained. Coupled to our biosensor, we have a fully personalized app that our patients can use to self-monitor them. In our app, they can create their own personal profile, where they basically keep a record of their latest exam results, and they can create their seizure diary to take notes of symptoms, etc. On top of that, they'll be in constant touch with their neurologists, who also have access to the platform. If they want to, they can also talk with others, with other patients that are using our platform and share their experience. I hope you enjoyed this presentation, and see you soon!